All right. Any questions on last night's homework?
Yeah.
Lainey, go ahead.
Okay, on 25.
25. Let me get there real quick. Okay, got it.
I didn't know if it was opposite angles or congruent or consecutive angles or supplementary.
Does it matter? Because once you know ABC and ABC, you could use consecutive angles supplementary, right?
Yeah.
Or you could use opposite angles congruent. Yep, it could be either of those. Yep. Gavin? 33. Okay, are you just struggling with the V one, with the fraction? Okay, since that's a parallelogram, what do we know? What do you guys know about the diagonals? Diagonals bisect each other. Okay? Since the diagonals bisect each other, then what has to be true in that diagram? Okay, what though? 33. What would equal what? 6 equals V over 3, right? Okay. And if 6 equals V over 3, then how do I finish solving this, Jacob? Whoops. Do what on both sides? Say that again. Okay, multiply by 3, yeah. Which would be like 3 over 1. I got what you're saying. Okay, but on both sides, right? So V equals 18. Okay, and then on the other one, you have 2u plus 2 equals 5u, is it plus 10? Minus 10. And you could solve that from there, right? Yeah? Okay, don't worry about that, guys. You're going to have to not be distracted by that. I'm going to video this class a lot throughout the year with basketball, okay? Because we do well in here. Okay, any other questions? No?
How many steps were you supposed to have?
Some people got 4, I think. Maybe 3, somebody told me. I think it was probably 4. I can't tell Seth what he said. 4.
How many steps are supposed to be on 56?
Probably about the same. 4.
5.
4 if you didn't include one of them in the same step. 2 could have been in one step. Yeah.
If it's okay if I have 5,
Yeah, that'd be fine. What? Yeah, it's supposed to. It's okay. It's okay, guys. Guys, calm yourself. You're gonna have to get used to that. It's this. Make sense now? Okay. Now that our amazement is done. Okay, what, Taylor Hart, from yesterday, what is one way or one thing you know about parallelograms? Opposite sides are congruent. McKenna, what's another one? Opposite sides are parallel. Travis? Consecutive angles are supplementary. Jacob? Diagonals, what? Oh, okay. Go ahead, Ryan. They bisect each other. We're missing one. Maya? Opposite angles are congruent as well. Good. Okay? So we have 5 ways or 5 things we know about a parallelogram, correct? Okay? Go ahead and hand your assignments in real quick. Sorry, I'm getting ahead of myself. Hand your assignments in. Yes, we have 5 theorems today. Yeah. You need another sheet? Show me your pink sheet and bring it on up.
Wait, how many are we going to have
Five. Oh, it's in your pink sheet? I got it. Photocopy.
It's not a photo. I like this stuff. That's my kind of work.
All right. So, moving on to today's information. Yesterday, we were told that it was a parallelogram, and we had to prove information about it. Thanks, Wayne. And we had to prove information about it. Today, they're not going to tell us it's a parallelogram. Okay, they're going to tell us it's a quadrilateral, and then they're going to tell us some more information, and they're going to want to know, can I prove that it is a parallelogram? Okay, so we're going in the opposite direction this time. Okay, so instead of knowing it's a parallelogram, we're proving that it's a parallelogram. Does that make sense to everybody? Okay. So we're just going to start off right away with our first theorem. Okay, we're going to have 5 theorems today. 4 of them are just going to be converses from yesterday. Okay, and a converse is what? Opposite. So you switch the hypothesis and the conclusion. Okay, so the first one we are going to call, and remember this all goes underneath your parallelogram theorems. Okay, but we are going to call this opposite sides converse. Okay, opposite sides converse. Okay. Now, if it's the converse of the opposite sides theorem, what's it probably going to say? Right. If the opposite sides are congruent, then it's a parallelogram. Because yesterday it said if it's a parallelogram, then the opposite sides are congruent. So now we're just switching it. Okay. So if a quadrilateral has both pairs of opposite sides congruent, then it is a parallelogram. And your diagram to go with that is just going to be a quadrilateral. Okay, and it's going to show you that both pairs of opposite sides are congruent. Does that mean that all 4 sides have to be congruent to each other? No. When would they all be congruent to each other? If it's a square, good. Okay? Now, right now, we have 2 ways to prove that a quadrilateral is a parallelogram. Okay, one of them is opposite sides converse. And the other one we haven't talked about yet today, but we talked about it yesterday. It's going to be definition of a parallelogram, which says what? Anybody remember that from yesterday? Definition of a parallelogram. If both pairs of opposite sides are parallel, then it's a parallelogram. Okay? So if I drew you a diagram and said that, or showed you that both pairs of opposite sides were parallel, would that then be a parallelogram? Absolutely. Okay? So just keep that in mind. We don't have it as a theorem, and we aren't going to work on it today, but definition of a parallelogram is also a way to prove that something is a parallelogram. Okay? Our next one, not opposite sides, but the next one is what? Opposite angles. So I have opposite angles converse. Which is going to say what? Well, the original said that if it's a parallelogram, then opposite angles are what? Congruent. So the converse is going to say if the opposite angles are congruent, then it's a parallelogram. Okay, so if both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. Yes, sir.
Must be on the classroom.
What's that? Yeah, the link to my YouTube channel will be on Classroom, and then this will just be found on YouTube. Okay. So we have the same diagram basically, except now I have opposite angles. Taylor, give me one name or one pair of opposite angles. B and D. Taylor Stokes, give me another pair. A and C, good. Does that mean that all four of those have to be congruent to each other? No, just the opposite ones. Now, could they all four be congruent to each other? Yes, they could. In what shapes? Or rectangles. Squares and rectangles, they would all be congruent to each other. Okay. Questions on that one? We're going to kind of fly through here and get our 4 theorems down, and then we'll talk about them. Okay. The next one is consecutive angles converse. Which we know, if it's a parallelogram, what do you know about consecutive angles? So they're supplementary. Okay, this is going to say just the converse. If an angle is supplementary with both of its consecutive angles, then the quadrilateral is a parallelogram. So what that's going to look like, that's going to look a little bit different for us. If this is x degrees and this is x degrees, that means angle B or D has to be 180 minus x degrees. Because if I took 180 minus that other angle, that would tell me what that measure is, correct? Everybody ready for one more? Okay. That's going to be which one? Diagonals bisect converse. Okay. The original said that if it's a parallelogram, then the diagonals bisect. So this one's going to say what? Good. If the diagonals bisect, then it's a parallelogram. Okay, so if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Lainey, do I have diagonals up here right now? No, I don't have any. Where would one be at? Royal, where would one be at? Point A to C. So Lainey, the other one is where? B to D, there you go. Okay. If that's the case, to prove that this is a parallelogram, what would have to be marked on there, Matthias?
BE is congruent to DE. AE is congruent to CE.
Good. BE would have to be congruent to ED, and AE would have to be congruent to CE. Does that mean that CE is congruent to DE? No. It might be, but it doesn't have to be. Okay, so just be aware of that. Alright, so let's roll through those real quick. Taylor Arnett, what is one way to prove that a quadrilateral is a parallelogram? Opposite sides converse, which says the opposite sides are congruent to each other. Seth, what's another way?
Opposite angles converse.
Opposite angles, which says
Opposite angles are congruent.
the opposite angles are congruent to each other. Paige, give me another one.
Consecutive angles converse.
Consecutive angles converse, which says what?
That if the angle is supplementary with both of its consecutive angles.
Good. If one angle is supplementary with both of its consecutive, then it's a parallelogram. McKenna, what's another one? Diagonals bisect converse, which says good. If diagonals bisect, then it's a parallelogram. Anybody remember the fifth one? It's not term from today. What is it? Definition of parallelogram, which just says if both pairs of opposite sides are parallel, then it's a parallelogram, correct? Okay. So what I want to do is go ahead and get this proof copied down for me. I have a quadrilateral here with P, Q, R, S, and T in the middle. Actually, yeah, it's a quadrilateral. And they tell me that triangle PQT is congruent to triangle RST. You guys don't necessarily need to write down those givens and proofs because we're going to put them over here in our two-column proof. Okay, so get that diagram copied down and then get your two-column proof set up. Make sure you're getting this statements and reasons two-column proof set up properly. There's a lot of you who are slacking off on it. Okay, it's going to cost you points come final time. Your final is going to be, we're probably going to start it next Friday. We'll probably do the proof portion next Friday, so we get that out of the way. And then after that, we'll have about 60 multiple choice for the finals day. Okay, but your proof portion of your final is going to be a pretty good chunk because proofs are worth a lot of points. Okay, so you're going to have to be able to do these. Okay, my givens are that triangle PQT is congruent to triangle RST. Think you know the next step, Rob? Oh, go ahead.
Can we use our fan sheets on there?
Yeah. Absolutely. All right. Jacob, what do you think? Okay. Reason? Now, I would agree with you if I knew that was a parallelogram. But I don't. That's what I'm trying to prove. You're really close, though. Taylor?
Well, if you know that those two triangles are congruent,
Yeah.
you can say that two of the sides are congruent to each other.
Okay.
And then you can prove.
First, before we go any further, I'm going to let you finish this. Right now, I'm telling you that the top triangle is congruent to the bottom one, right? Just so everybody's on the same page. Okay, go ahead, Taylor.
You can say that PQ is congruent to SR.
Okay, let me get that real quick. PQ is congruent to SR. Does everybody agree with that? Okay, what's the reason? Good. PQ is congruent to SR because of CPCTC. Always the next step after proving triangle is congruent, correct? Okay, so if we just prove triangle is congruent, which we did, then your next step has to be this. Okay, it has to be. There's no other options. Okay? Now the question is, so that's kind of looking like we're going after opposite sides congruent, right? You guys agree with that? Okay, and everybody agrees with what Taylor said. That's definitely true. Okay, now the question is, to prove this because of opposite sides converse, right? It'd be opposite sides converse. I also have to get these two. Right? Okay. The problem is, I don't know that these two triangles are congruent. So I can't say RQ and PS yet. Now, I could go ahead and say that, well, because of CP/CTC, PT is congruent to RT, and ST is congruent to TQ, and then I could use vertical angles, and then I could use CP/CTC again and prove these sides congruent, right? And then I could use opposite sides converse, right? But that's a lot of steps. Royal, what did I do in the process?
Get diagonals, bisect, converse.
I ended up getting diagonals, bisect, converse, didn't I? Now, does that mean Taylor's wrong? No, because that's true, isn't it? Okay, so don't think you have to erase if you put something like that, because that's a true statement. Okay, but after you write that, I want you guys to be able to notice, hey, that's not really going to get me anywhere right away. Okay, now sometimes might you have to take that many steps to get to the end of a proof? Yes, you might have to. Okay, but as you're thinking through that, Royal noticed, well, hey, I said that PT was congruent to RT, didn't I? Well, why is PT congruent to RT? CP/CTC. Okay, and why is ST congruent to QT? CP/CTC, right? Okay. And then, hopefully at that point, you notice that, hey, I just set this up, and now I have what happening? What are my diagonals doing? They're bisecting each other. Okay? Is everybody with me there in the back row? With us? You with us now though, right? Okay. Okay, so make sure as you're going through that, you just recognize what you're doing. Because now what can my third step say? It can say that PQRS is a, and they're going to start using this symbol on you, so you can start using it as well. Okay, that stands for parallelogram. Okay, so PQRS is a parallelogram. Why? Diagonals bisect converse. Good. Okay. Now, let's say I went ahead and proved PQ congruent to SR first, and as I went through, I didn't notice that it changed to diagonals bisect converse. Are you going to get the proof wrong if you ended up doing all those steps we talked about and then proving it a parallelogram? No, because you still proved it's a parallelogram, right? Okay, and that's what matters. Okay, so remember, you might do it differently than somebody else, and that's perfectly fine. Okay, you might take a longer route than somebody else. That's perfectly fine. And I'm not telling you it's wrong. I'm just giving you hints on how to find shortcuts. Okay? Any questions on that proof? Okay, you're going to have 2 more proofs today on your homework, just like you did yesterday. Okay, I know we've had a lot of theorems, but we do have 1 more. Okay, we ready for 1 more? Okay. The very last one that we have for this section is called opposite sides, and this is the last one underneath your parallelogram ones. It's called opposite sides, congruent, and parallel. What do you suppose is going to happen in this theorem? Opposite sides are going to be congruent and parallel, right? Okay, so if one pair, it only has to be 1 pair on this one, of opposite sides of a quadrilateral are congruent and parallel, then it is a parallelogram. I will give you a diagram real quick. It would look like this. Just keep in mind it does not have to be the top and the bottom. It could be the two sides. That would be fine. Questions on any of those theorems? Alright, now remember, we do have a quiz tomorrow. Okay, all class periods have a quiz tomorrow. And also, remember that second quarter work is due before lunch on Friday, December 16th. Okay, so if you come in at lunch on Friday, December 16th, and you want to take a test, what am I going to tell you? I'll say, no, it's already in as a 0, I already recycled them. Okay, so get your stuff taken care of if you have tests or quizzes to make up. Okay, before we go or start our assignment, okay, I want to quickly review those things that we just talked about. Royal, what is one way to prove that a quadrilateral is a parallelogram?
Is the opposite sides
Opposite sides converse. So if opposite sides of a quadrilateral are congruent, then it's a parallelogram. Maya, what's another one? Opposite angles converse, which would mean opposite angles are congruent. Paige? Consecutive angles converse, so consecutive angles are supplementary. Carly? Diagonals bisect converse, which would mean that if diagonals bisect, then it's a parallelogram. Ryan? Opposite sides congruent and parallel, which is the one we just did. There's one more. What do you think, Taylor Stokes? The definition of a parallelogram. Okay? Definition of a parallelogram. Okay? Any questions on any of that lesson? Okay, I do have the quiz review as part of your assignment today. Oh, actually, sorry. We're not quite done. Let's quickly look on page 342. Number 2. Carson, is number 2 a parallelogram? Reason. Opposite angles converse, or opposite angles congruent converse would be fine. Amanda, number 3. Yes. Reason? For opposite angles, it would have to be both pairs. So do you know both pairs are congruent? No, so it must be consecutive angles converse. Good. Carisha, number 4. Yes, reason? No. Careful. Those aren't congruent marks. I agree with you that it is. Yep, they're parallel, which means the reason is what, Jacob? Definition of parallelogram. That was from yesterday. You were gone yesterday, weren't you? Okay, that was from yesterday. Okay, definition of parallelogram on that one. Okay? Alright, now we can do our assignment. On page 342. What's What's that, Royal? You got suggestions?
What was it?
Oh. 9 through 19. Your two proofs are 32 and 33. And I also need you to do page 346, 1 through 4. You will have to know distance and slope formula today and tomorrow for your quiz. Number 4 on this quiz uses distance and slope formula. Okay, that's the only hint I'm giving you for number 4. It does use distance and slope formula.